Question 2. Here we're asked to do the gradient function. So have a look at the turning point. The gradient at the turning point is 0. So right below where it crosses, you put a cross on 0. Now do a gradient of, say, 1. I've used the axis there from -2 to 2 is 1. Shift that line so it touches the original function, and right below that draw a 1. You can take another point, let's say 2, that goes from -2 to 4. There's the gradient of 2. Shift that line so it touches, and right below that draw in the the value for the height to represent the gradient. Now just join those 3 dots up. We're only asked to sketch the graph, so it doesn't matter if it's slightly different. It doesn't have to cross at 4. Somewhere like that. A similar graph to that. We know that that was a y equals -x squared type graph, and when you differentiate it, it's going to be a -2x type graph. So it has a gradient of -2, approximately. This one here, we're given the differentiated equation, and we want to find the original. So we're going to have to anti-differentiate it. Write it out, and then add 1 to the power, divide by the new power, simplify. Add 1 to the power, divide by the new power, add your constant, simplify. It passes through the origin, so the constant must equal 0. We've got the value of positive 3 there. Put 3 into the equation, work out what the answer is. We're asked for the coordinates, so write the coordinate as an xy coordinate pair. That will give you achieve level. For this one here, we're given the velocity, and we're asked for the distance. So what we're going to have to do is we're going to have to anti-differentiate to get from velocity to distance. So write out the velocity equation, add 1 to the power, divide by the new power, and simplify. Add your t and your constant, and so that is your distance equation. Now what you do is you take the value of 9 and 3, you can work out what c is, change sign, calculate that, then rewrite your distance equation, and all you're asked to find is the distance after 20 seconds, so put 20 seconds into that equation, and you'll find that it should come to 99.1 meters. That's for merit. For this question, we've got a profit equation. We're told that it's decreasing. If it's decreasing, that's a rate of change. We're going to have to differentiate it. So we differentiate that, and it's decreasing when it's less than 0, t. We've got no profit, so we'll find the beginning point there, and change sign. Remember, when you're dividing by -0.02, to also reverse the inequality. I've times the 0.75 and the 0.02 by 100 each, so that we have a nice simple equation. Now, or inequation. Now it's also decreasing for less than when t is greater than 45 months. So if it's decreasing for both of those, make them equal, and you can solve it. Both of those equal less than t, and so you can make them equal and solve it. Maximum velocity, that means we're going to have to differentiate to find a maximum. I've expanded the brackets before I differentiated. We're differentiating with the small r, the radius, so we've got v dash equals 2k big R times little r. I've reduced the power by 1. Same with the second term. Now we can factorize. We've got a common factor there of k and a little r. So factorize the k and the little r, because it's a maximum, has to equal 0. Now the first bit could equal 0, so r could equal 0 there, or the second bracket could equal 0. So you solve for that, and we have our 2 answers. One's a minimum and one's a maximum. How do I know which is which? Well, it's a -r cubed, which looks like that, and the minimum comes before the maximum, so the 0 will come before 2/3 of r. You could also double differentiate to prove it. And there we are, we've got extended abstract thinking. That's excellence.